All right, so now we're just going to do some examples of those component-wise limits. And first one we'll do is easier. The second one we'll be harder. So first we're going to compute the limit as t goes to 2 of f of t for f equal to t squared minus 3I hat plus e to the t j hat plus sine pi t k hat. That t is kind of out of line. Let me fix that. K hat. Okay, so what I want is the limit as t goes to 2 of t squared minus 3I hat plus e to the t j hat plus sine of pi t k hat. And I need to do this component-wise. Rule for vectors is almost always going to be that I, j, and k stuff all act independently of each other. So this is going to be limit as t goes to 2 of t squared minus 3 I hat plus the limit as t goes to 2, bad 2, of e to the t j hat plus the limit as t goes to 2 of sine pi t k hat. And so now, ignoring that this is about vectors, if you just look at that quantity, limit t goes to 2 of t squared minus 3, hopefully you know how to do that. You say, okay, well, 2 squared is 4, minus 3 is 1. So this is going to be 4 minus 3I hat plus e to the 2j hat plus sine 2 pi k hat. So that's just I hat plus e to the 2j hat, and then sine of 2 pi is 0, so that drops off the answer there. And that's a simple example of computing a limit of a vector valued function, just remembering that we do every component separately. And then this also works if we need to use L'Hopital's rule. An exclamation mark. So we're very excited about this next limit example. And this one is going to be like your practice problem, so follow through with me. It's going to be the limit as t goes to 0 of sine t over t I hat plus 1 minus cosine t over t j hat plus e to the 1 minus t k hat. We want to compute that limit. And so just like before, our rule is going to be that we look at every component separately. But now these limits aren't so easy. Sine of t is 0, but t is 0 as t approaches 0. So we've got that 0 over 0 we have to deal with. Same with 1 minus 1 is 0 over 0. This last entry actually is fine, but we're going to start from the left. So instead what we have to do is take the limit as t goes to 0 of the derivative. So derivative of sine is cosine t. Derivative of t is 1. Derivative of 1 minus cosine t is positive sine t. Derivative of t is 1. Actually, we won't rewrite that one. Then I get over here and I say limit as t goes to 0 of e to the 1 minus t is e to the 1 minus 0. That's just e to the 1 k hat. So there's one entry that we didn't really have to fool with. But now we can go ahead and take these limits as they're written and end up with actual numbers for answers. So we've got as t goes to 0, cosine 0 is just 1. So we've got 1 I hat. T goes to 0 of sine is 0. So plus 0 j hat plus e to the 1 k hat. So we could go ahead and write that back in this bracket form just to get good practice with it. 1, 0, e to the 1. That would be the answer for this problem. And your, okay, not going to bother with that line. Your practice problem is going to be one of these that requires the derivatives from L'Hopital's rule to compute the limit. It won't be exactly like this. It'll be different functions, I think. Note, if any entry of your vector has an undefined infinite limit, then the entire vector valued function is entire vector valued function's limit is undefined. The reason for that being that, like, even if you got 1, 0 in the first two entries and then infinity in the last, that's really not like a finite vector. You can't draw that on a piece of paper. So one entry going bad is going to ruin all the rest of them, just so that you know that for the future.